Hello for the motion canvas developers and welcome to a new episode. Today I have something very special for you. We're going to analyze how a component works from down to its bits. Why did I make like this? Because it's a very good joke. Since it's a bitwise component. Yeah, don't click off this video. I think you get to the point why this channel has 0 views so far. But I think if you're a motion canvas developer, I know if you're a motion canvas developer, you're going to learn something from this video. So we're going to analyze how I made this component, its inner workings, and you don't have necessarily to use bits in your videos or anything like this, but what I try to do here is show you how to create generally a component, how to organize it, and have some ideas when coding a component from this video for your video. You get my point. I think I don't have to make the situation even more awkward. So we're going to get into the inner workings, because I think you already saw the animation, the code. I will explain it very briefly. We first initialize the component to add it to the view so you actually can see it. Then we use a random generator here to generate some random numbers, but first we pop the component so it is on the screen using the pop function. Then we load the number 15 decimal form, of course, and in binary form it looks like this. Initialize a number with a number of bit groups, where a bit group is 4 bits. Now I know a bit group is generally a byte, so 8 bits, but for this video I need to subdivide it into 4, so yeah, I guess get it. Also an initial number, this is 6, the one from here. So after we load 15, we wait a second, then we show the decimal, which by the way can be a hexadecimal. Hexadecimal, is that a name? I don't know, but you get my point. And then I show a couple random numbers and I pop the component. There's the inner workings. Now let's see how it actually works. 2 minutes. Okay, I'm now moving to slow to fast. Is perfect. Those are the initial properties. So let me get to read briefly. So show decimal and show hex. Basically, you see here, 1 represents the decimal number is appearing on the screen, 0 means it's not appearing. Those are some signals, so you animate them like you've seen earlier. So it goes from 0 to 1 here, which means the decimal representation is appearing. And also I would like to modify something really quick. So layout. What if I do this? Yeah, I think it's a bit better now. Is it different at least? I don't know. Anyway, so again, back to the point. Number itself, the initial value of this component, of course. The bit groups again, which represents 4 bits, so 4 boxes on the screen. If we give more bit groups, so like 3, we get 12 boxes, 16 boxes, and bit groups we can give it 8, which is, by the way, how many bits an integer stores, which is pretty crazy if you ask me. Those are quite a lot of bits just for a single number. Okay, so this goes to the point of always be careful if you're coding with small numbers, not reserve those many bits for literally no reason. You probably never go past this number with most of your values. Okay, now it's also good to not overcomplicate your code with optimization, but I don't know, I guess you get my point. So back to the original example. This is a byte, again 8 bits. Then how the actual component works. I present this. Initial visibility means the component is visible without targeting the pop function, so it instantly appears on the screen. It's important to get this get binary function. I mean, to know at least what it returns. It gets decimal number and a bit amount, which is basically how many bits it should extract from that number, and then it will put in a binary array. So every single bit basically. So the binary array is as big as bits amount, and this means it's shifting by an offset which increases by 1 by each iteration, and gets the last bit of that offset, which inserts inside of this binary array. Okay, I hope that makes sense. So this array is full of 1 or 0. This means that it's adding in reverse order. If it was only y, let's say for the number 4, which is this, not this, sorry, this, it will have stored it as this, inverse. But if we're going to use notation from earlier, it's going to reverse it so it's stored perfectly. Now I'm initializing the properties. We're going to discuss those ones in a moment. You can take a look at the values if you want. Visible basically means the component is visible on the screen. It's using the pop function, so it checks if it should pop on or pop off. Boxes is where those boxes stored, and I is basically the box index. We'll take a look at it. We're adding two texts as the first and second child of the initial class. It's pretty important to grasp this because we're going to animate them in a moment. So this is the text for the, what is this? The hexadecimal. This is a text for the decimal. Okay, so here the width of the text depends on the hex color we have here, which is used strictly for animating when popping in and popping off, and show hex, which we give in the properties, which basically describes if the hexadecimal should be on the screen or not at all. Same for the decimal number here. Okay, one used for animating, one used for knowing if it should appear. Okay. So load is a very important function. It's the function where we load a new value inside of the binary representation. So in the load we basically change the current value. So if it is a different value at all, we're going to spawn this generator function. I don't know why I haven't made this auto generator function, but yeah, I guess doesn't matter now. And it animates as this, the first two children. It basically gets them to opacity 0.2 very fast and then back to 1. So this is used for the decimal presentation and the hexadecimal representation to flicker when they change. You see, they don't simply change. So, oh yeah, now it doesn't change at all. Yeah, you see. So this is how it looks normally if you want to change it, but if you animate it, it looks like this, which is better in my opinion. So then we're going to, and also my opinion is right always, we're going to get this decimal number, which is either a new value if you have one. If not, we're going to get a decimal number, which is basically the current value. I don't know, it's pretty obvious. And the bits amount, which is basically the bit groups multiplied by 4, and we're rounding this number. And now binary, which is the array we've talked about earlier, with every single bit of the number, the one from that function. Okay, and we're putting the y at 0, and then we're going through a very important for loop, which is also used for loading new boxes and for updating the current ones. This is used for creating new boxes. This is used for updating. Let's get into the first one. So first we create a box. So if this is y, whether the box is length, this means there are more bits than there are boxes on the screen. So we have to create new boxes, right? So we're going to create a box like this, insert a text inside of it with the binary bit at that position, this at y, and then insert that box inside of the component so we can actually see it. And if the component is already visible, we can animate this by putting the box scale at 1 and the opacity of the text at 1. Okay, pretty straightforward. And by the way, spawn basically runs the generator function as if it was not a generator function. I mean, if it was generator function, but in a non-generator context, I think you get what I mean. If not, just read the documentation. It is awesome. It has everything you want over there. And this is basically the part where we're adding new boxes, okay? Then here is where we update a new box. So we first identify the box. This that box, this that y. We find the text of it, which is basically the first child, because it only has one child. And we read a new bit number, which we should update. If it is a different one, as you see here, if you take a look, the bits that don't change, don't move. As you see, this one is staying still. So that's why, because of this if from here. If you were to remove this one, you will see the entire number will change. But I like this effect where only the required bits will update. Okay, so it checks if the bit is different at all, and then if it is, it creates a new text. I don't know if we can actually see it. Let's go in this box. Where is it? So this is the box, and it has two letters, right? So first it has one up, which will spawn when we start the animation, and then it moves like this. You see, we create a new letter by cloning the old one, yeah, and then we offset everything by a given number, and once the offset is done, we remove the old letter. Okay, so that's how this effect is done, and it gets removed. Same for this. Okay, of course we give the new text the required bit. The box, we're adding the text into the box. Okay. A little bit tired, sorry if I'm stumbling, but I've recorded this video over and over again because I keep failing at talking at the camera, but hey, I guess I'm learning. Then if there are more boxes and bit groups, which I don't know why will appear, we can also remove them. So we first extract it from the array by removing it. That's why there is an exclamation mark here to keep it in a variable. I think I forgot to read the meaning because I just stole this code from the example from motion canvas. And basically I animate the box size to go to 0. So this theoretically means we can also animate bit groups, but I'm not sure if I want to try that. There's really no reason for it. Okay, that's how the load function works. So a recap, very quick. First it checks if there are more bits than boxes, and in that case it adds more boxes. If we're only updating the value, it checks if the bits have been updated. If not, they are updated using this animation I presented earlier, where we're creating basically two letters. And then if there are more boxes and bits, we're going to remove them. That's basically it. We have also the pop function, which is very simple. If the component is visible, we're going to yield this entire sequence, which makes it invisible, so it sets the opacity to 0 and stuff like that. Also, if it is not visible, we're going to make it visible, and we're inverting its visibility. Now, I think that's it basically. Yeah. Also in the pop function, I'm animating the hex color, so it goes to 0 when the entire binary pops out. So that's why it is used. Also the decimal scale. I don't know how well this explanation was, but I think that's it. Okay, we're creating boxes for bits, we're updating them when needed, and yeah, that's the component itself.